Physics వచ్చేసింది.
Okay, good afternoon, everyone. And
Good afternoon.
Your syllabus, that is your syllabus mechanics. And last class lo manam vector field, scalar field, and vector integrations, and vector of a curl of a vector field, Stokes theorem, వీటి గురించి డిస్కస్ చేయడం జరిగింది. And discuss about Gauss divergence theorem. Okay, is Gauss divergence theorem is what is the statement of Gauss divergence theorem? Say, just wait. So, Gauss divergence theorem. The surface integral of A, that is, surface vector integration is three types. That is a line integral, vector integral, and line integral and surface integral and volume integrations. Last class lo discuss cheyadam jarigindi. So what is Gauss divergence theorem? The surface integral, that is the surface integral of a vector along a closed surface. Surface integral means that is the double integration.
Madam, we didn't see any video, madam.
Okay. So Gauss divergence theorem, that is surface integral of a vector along a closed surface is equal to the volume integration of the divergent of a vector field. That is surface integral means that is double integration. So surface integral of a vector along, that is vector means, let us consider F or A or B, anyone. So along a closed surface is equal to the volume integration. So closed surface kabatti, that is S, that is equal to, then equal to volume integration of the divergent of a vector along the closed volume. Volume integral means that is triple integration, that is x-axis, y-axis, z-axis. So that is volume integration of the divergent. Divergent means del dot A, that is the vector. A is the vector along a closed volume, that is called the Gauss divergence theorem. So once again I can explain that a statement is surface integral of a vector along a closed surface is equal to that volume integration of a divergent of a vector along a closed volume. That is the statement of this equation, that is the theorem is proof that surface integral of A dot ds is equal to volume integration of del dot A into, that is volume kabatti this is dv. So దీని proof, then this theorem is proof that surface integral of ADS is equal to volume integration of divergent of A into dv. What is the proof? That is, let us consider a closed surface S. Then consider a coordinated system, that is x-axis, y-axis, and z-axis, and that is divided into number of cubical elements of the area, that is ds of a volume is dv. Okay, so see, this is, let us consider then one cube. So x-axis, y-axis, z-axis, that is x-axis and y-axis and z-axis. This is origin. So then this is dv, and xi, this is dx length, dy and dz. So total, that is dv is equal to volume is equal to dx, dy, dz. So then here one side, let us consider Then consider a closed surface. This is the S. Closed surface. Consider a coordinating systems inside the closed surface. Inside the closed surface. This is inside the closed surface. Let the system is divided into a number of cubical elements of this area is the ds. Okay, that is ds area. So of the volume is dv. Let that is a be a vector and n be the unit vector. A is the vector, you know, that is a is the vector. Let us consider a is the vector and n, that is n is n cap, that is unit vector. This side, see, so don't write. See, this is consider cube, that is x-axis and y-axis and z-axis, and this like that, this side, this side you consider, so this side just like, okay, and this is ds term. Okay, this side you can draw this left side, then this is the unit vector and vector field, that is the angle of theta. So a be the vector field and n cap is unit vector. Let theta be is the angle between a and n. So let us consider closed surface, that is S, and coordinating system inside this closed surface. So let the system is divided into a number of cubical elements. Number of cubical elements. Wait. A minute. So let A be the vector and n is the unit vector, that is the n and a is the angle between. So the total flux is dividing for unit volume is taken as the, that is divergent of A. Okay, total flux is dividing for unit volume is taken as the divergent of A. Flux coming out the volume dV is equal to the, that is the integral of del dot, that is divergent or del into dV. The total flux, then total flux coming from this entire volume, so that is integration of uh, del dot A into dV. Then theta is the angle, so that is A cross n vector, so that is unit vector. Then A cross n cap is equal to, that is A dot n is equal to an cos theta. So what is A cos theta is like that. So then flux coming out through the area ds, then or this value, so simply then that is the coming out of through the area, that is ds is equal to then A dot n cap and into ds. So that is A dot ds. Flux coming out from this entire surface, that is integral of A ds. And this one and this is divergent A into dv. So that is both are equal. Then flux coming, and both, that is both equations are represent the entire flux coming out from the surface with the respect to the volume, and surface area is respecting, that is the divergent of dv is equal to, that is integral of A dot ds. So that is the divergent of A dv. Then this is the Gauss divergence theorem. So what is the proof that Gauss divergence theorem A ds is equal to del dot A volume integration of and surface integral of del dot A into dv. That is the Gauss divergence theorem is that like. So another one, that is another proof, Gauss divergence theorem. Let us consider one cube that is x-axis, y-axis, and z-axis. So let us see. 1 minute. One figure I am screen share. So let us take three infinite similar areas. So x-axis and y-axis and z-axis. See, this when I share screenshot. See, first of all, we observe that. Let us take three infinite similar, that is the rectangular areas. Okay, so that is center O point as shown in this figure. Okay, this O, this is the O, and this is O, and at O is componenting the vector field is like V. So that is Vx axis and Vz and Vz, Vy and Vx. That is along XYZ action directions. The normal of these areas will be respectively. Then the position of x-axis, y-axis, and z-axis directions. Okay, so this figure indicating the positive sense in this which boundaries of this area must then right hand screw rules of vector area. So this applying the right hand screw rules of vector area. Let us consider. Then let us consider that is let cube like a this is a like a cube. So x-axis, y-axis, z-axis. So let us consider that is the A. This is C. Observe that this is A, B, C, D. Let us consider area is the A, B, C, D with dx and dy. That is the sides of dx and dy. The normal of these area will be along a z-axis. Okay, as the area of this rectangular is very small, and that is the component of V. That is V is the middle of any side may be taken as the average value along that side. This arrow, okay, this arrow mark, that is this is the arrow indicating the direction in which the respective components acts. As we have taken that is Vx, Vy, Vz as the function of the coordination, that is x, y, z of this center of the rectangular area. Then this average value along the four sides of the rectangular will be followed. Then along this rectangular, that is the A, B, C, D. So then this is the x-axis. Then let us y. Then y along with the, that is one side. This is a. So let AB side. This is along with this average values values along the four sides of the rectangular. Then first of all, along AB side value is that is Vx minus of dou Vx by dou y into dy. So similarly, that is along BC side value. So that is positive. This is the downward. That is the value is negative. So and another one, that is BC side. So that is value is Vy my plus 1 by 2 dou Vy by dou x into dy. And again that is CD side. So upper side. So that is x direction. So then you let us consider only that is ABCD with the dx and dy on its sides. So the normal this area along with the z axis. Okay, so only x, y, z direction, that is ABCD rectangular. Then Vx, then AB, and CD is the value of Vy plus 1 by 2 dou Vy by dou y into dy. So similarly, then that is CD side. Then CD side means, so that is the value of Vx plus of dou Vx by dou y into dy. And again, that is AD. So that is Vy minus of dou Vx Vy by dou x into dx. This is Vx, Vy, and Vz. These of these coordinates, that is x, y, z, of the center of the rectangular areas. The average value along with these four sides of the rectangular. So that is and then these four A, B, C, D rectangular, that is the line integral along the ABCD path. Then will be this AB plus BC and minus CD and minus AD. These values are all add. So total like that, that is dou V. So that is these values are adding. Then simplification, we get the value is dou V y by dou x minus dou Vx by dou y into dx dy. Okay, nothing but dx dy is represent the area of, that is ABCD. Then that is the value of unit area. ABCD, a value of area. So these components, then along this value is z direction. So this component of curl along the z direction. The unit vector along the x-axis, that is k. So this x term, this is the x-axis lo తీసుకున్నాం మనం. So x-axis is k. Then and hence this component of curl along the z direction. So curl along this z direction. So kabatti, so curl z v is equal to dou Vy by this value is curl z axis, that is the v. Curl v is equal to dou V by dou x minus dou Vx by dou y into dx dy. So that is this is the into k. So z axis, so let unit vector along the x axis is k. So that is into k. And another component of the curl can be written as y. So here that is dou Vx by dou z minus dou Vz by dou x. Then this is the y direction. So that is the value of curl y into, that is v. Curl v is equal to, this is y direction means y axis is component along with the, that is the unit vector is z. So similarly, let us consider, this is the simplification same as it is. So x direction, x direction. So unit vector along the z axis. So x axis. So what is the value? Dou Vz by dou y minus dou Vy by dou z into I. So total of this curl, this is curl x direction means. So total curl v is equal to curl x vx, curl y v, curl z v. So these are terms is, then simplify that value is, let curl value we get. So that is curl v is equal to ij k dou by dou x, dou by dou y, dou by dou z, that is vx, vy, vz. So that is curl is equal to ij k into dou by dou x, dou by dou z, dou by dou y, that is simplification of last class. This value is simplification in last class. I have explained that. So that is simplification. Then we get the curl value. So what is the now, that is divergent. We are discussing divergent. What is Gauss divergent theorem? Gauss divergent theorem means that is surface integral of a vector field, that is vector field like A or F, anyone like F, A or F. So the surface integral, that is surface integral means double integration. A vector field F over the boundary of a closed surface, that is closed surface, is equal to, that is means, this means the total flux across S is equal to the volume integral of the divergent of a vector field, that is del dot F dV. This is divergent of a vector field is volume of the divergent of a vector field. That is called the Gauss divergence theorem. Then ఇది ఎందుకు ఎక్స్ప్లెయిన్ చేశాను లాస్ట్, దట్ ఈస్ కర్ల్ వాల్యూ we can find out na x axis, y axis, z axis. Similarly, same as it is Gauss divergence theorem, let us consider one cube and that is closed surface S and volume V is divided in large number of elements. Then each part, that is x axis, y axis, z axis, you know. So that is let us consider. Then similarly, that is the value of, so simply Gauss divergence theorem is in surface integral of the vector field is closed surface is equal to the volume integration of the divergent of the vector field. Then that is the volume is V enclosed by the surface. See here. So let us consider closed surface, then enclosed the volume is V. So this is one cube. Let us consider x-axis and y-axis and z-axis. This is x, y, z. This is length of dx. This is length of dy, and this is dz. So y, x, z. So this is entering the point and ending. This is the right flux is entering and end of this flux. Okay. So see. So what is the surface integral of a vector field over the boundary of a closed surface S? That means the total flux across the S. So this surface is S and volume is V, and divided into a large number of element values, that is dx, dy, dz. Then image one, then this coordinates, that is the x, y, z axis, coordinates of this lengths dx, dy, dz. Let that is the vector field is F. Let us consider of vector field, that is F acting over the left face. So the component of a field along the x-axis is, that is Fx. Okay, the volume consider, and the infinite of 1 and a flux over the left face is equal to the product of that is x direction, that is vector field is Fx. And that is, this is let us consider, this is the P1 and P2. This is left side entering in the flux and leaving in the flux is P2. So then flux over the left faces is equal to the product of, that is the x direction. So that is the vector field is Fx. And what is the area? Area is dy and dz of this face. And so flux through the left side face, that means P1. So what is the flux? That is Fx into P1. So dy dz, that is the area. So what is negative sign? Why? How? That is this is negative sign indicating for coming to the flux. This is coming to the flux direction. So flux through the right face. This is leaving this flux. So right face, that is P2. So what is the flux right face? Fx P2 dy dz. This is also same x direction. So flux through the left face and right face. Total flux is equal to, that is minus Fx P1 dy dz. This is dy dz is the area and vector field in x direction Fx, and that is P1 is the entering into the flux. So total flux through the left side. So what is total flux? That is left side minus Fx P1 dy dz. So what is the y? Sorry, minus indicating from incoming flux. And similarly, then leaving to the flux, that is the right side. So flux through the right face, Fx P2 into dy dz. So then this is leaving and outgoing flux. So that's why that is the place. So total flux, that so here right side face flux is right side flux is face, that is F2x. So Fx P2, what is Fx P2? That is Fx, that is P1 plus dou Fx by dou x into dx. So dou Fy, sorry, x direction. So dou Fyx by dou x into dx. So see. So first of all, what is right side and left side of the flux through the left face? So Fx P1. What is Fx P1 is equal, that is Fx P1 dy dz. This is left side. And right side flux, that is total flux, Fx P2. This is first left side, and this is right side left. So total flux means that is Fx P1 plus dou Fx by dou x into dx. So what is the right face of the flux? Total flux is Fx of P1 into dou Fx by dou x into dx. So total flux, this is left side and this is right side. Total flux means that is minus Fx P1. This value plus and this value. So here, so this value. Total flux means this value and total 1 and 2 equations. So total flux means that is Fx P1 dy dz and left side and right side. So plus Fx P1 plus dou Fx by dou x into that is into this area dy dz. So total ka dx dy and dz is common. So then simplify this value. What is the Fx P1 plus dou Fx by dou y? That is this value and this value is both are cancelled. And similarly, simplify this value. What is the final value? Dou Fx by dou x dx dy dz. Okay, this is only let us consider 1 cube and only x direction value. And similarly, y direction, dou Fy by dou y dx dy dz. And similarly, z axis, dou f z by dou z dx dy dz. So total flux through the flux all faces in rectangular is given by that x axis, y axis, z axis. Dx dy dz is common. So what is the value? Dou Fx plus dou x plus dou Fy plus dou y plus dou Fz by dou z into dx, dy, dz. This is the total flux. So what is the value? This one, what is the del? Del means I into dou by dou x plus j into dou by dou y plus k into dou by dou z. What is f? Means a vector field I f x plus j f y plus k f z. So I into I multiplication is that is I term, j term, and k terms. So del, what is means? Del means I into dou by dou x, j into dou by dou y plus k into dou by dou z. And what is f? F is equal to I into fx plus j into fy plus k into fz. So this del dot, this is del dot f means this value. This is the del dot f. These both are multiplied. Then simplify the value of del dot f is equal to dou fx by dou x plus dou fy by dou y plus dou fz by dou z. So the flux, all faces of the rectangular, so that is all faces of the rectangular, that is surface integral of f ds is equal to, that is del dot f into dv, dx, dy, dz, that means dv, small element of the that is dv. So that is the total flux through all elementary volume. So volume into which is the surface in this divided up we have, then surface integral of f ds is equal to volume integration of del dot f dv. This is the divergent of f. This theorem is proof. This is the Gauss divergence theorem. That is the, or you can write surface integral of f dl is equal to volume integration of div of f dv. This is very important question. Gauss divergence theorem and Stokes theorem and curl of a vector field. These are theorems are very important. Then related to these problems, um, I can explain that divergent and curl and grad. లాస్ట్ క్లాస్ లో మీకు కర్ల్ గురించి, డైవర్జెంట్ గురించి, కర్ల్ గురించి, డైవర్జెంట్ గురించి, గ్రాడియంట్ గురించి ఎక్స్ప్లెయిన్ చేశారు. సో వన్ ప్రాబ్లం లెటర్స్ సి, దట్ ఈస్ ద పొజిషన్ వెక్టర్ r. R is equal to, what is the position vector ix plus jy plus kz. This is the position vector r is equal to ix plus jy plus kz. So what is del dot r is equal to what the value? So del means divergent or write that like, okay, divergent or means or del r. Divergent means I into dou by dou x plus j. So first we can write what is del or divergent, anyone you can write that. So what is del? I into dou by dou x plus j into dou by dou y plus k into dou by dou z. What is the r? Position vector, that is ix plus jy plus kz. So del dot r is equal to what? So this del dot r. So del dot r means, so del dot r, that is r means ix plus jy plus kz. So what is I into I? 1. I into j, that is 0. I into k, also 0. So I into I, so only dou x by dou x. So I into j, that is I into j 0. So that term is 0. I into k is also 0. So similarly same, j dot j is equal to 1. J dot I equal to 0 and j dot k is equal to 0. So this term is multiplication in I, j, k. So dou y by dou z. And similarly dou z by dou z. So dou x by dou x means dou x by dou, what is the dou x by dou? That is the multiplication in simplification of that. Simplification value is, so dou x by dou x plus dou y by dou y plus dou z by dou z. That is the value of 1 plus 1 plus 1. That is value is 3. So this value is 3. Del dot r is equal to, what is the value in 3? What is, say, r is a position vector. You find out the value del dot r is equal to, what is the value? So use simplification del dot r, then that is the value is 3. So this is the one model problem of divergent. And again, see, another two problems I can explain that. See, another curl model problem and divergent also. See, we can observe that. See, one model problem and one model problem. Find the divergent of A at a point 1 minus 1 1 when A is equal to x square z I minus 2 y square z square y cube z square and x square xy square z into k. So this is the vector. What is A value? So what is the find out the divergent of A? Find out the divergent of A means del dot A. So del dot A means what is the del? Del means I into dou by dou x plus j into dou by dou A plus k into dou by dou z. So what is A? A is the vector. That is vector. So that is I into I. So these both terms is multiplication. So multiplication, then we have simplify that I into I is 1. Only I term. I into z is the I into I term. I into z. I into k. So I into z means that is I into I equal to 1 only. So I into z is equal to 0 and I into k equal to 0. So I like that only I term, that is I into I is 1. So dou by dou x into x square into z, that is I term. So similarly, j into I, j into I. So j into I means that is 0. So j into j, j into j is equal to 1. So 1 means that is this value minus 2 y cube z square. And again, then j into k, j dot k is equal to 0. That term is also 0. So similarly, z term is also k into I, k into I, that is also 0. K into z, k into z also 0. And k into k, k into k is equal to 1. So that dou by dou z into k term. So x y square z, k into k is the 1. So then simplification with respect to x. So dou by dou x means x square k differentiating, what is the value? 2x. Differentiating of x square is equal to 2x. 2x square into z minus, that is minus term, that is the minus value. So with respect to, then z is also constant with respect to only x. So that's why z is constant. Dou y by next y term. So minus 2z square is constant. So then y cube, derivation of y cube. Y cube means 3y square. That is the different derivation of the y cube. Y cube means 3y square. So already 2 undi. So 3 to the 6. 6 y square and z square. Then simplify value. This value 2 y 2 z square. So minus 6y square z square. This value. Okay, and next again z. So z with respect to z derivation. So x y square is constant. Dou z by dou z by dou z, that is 1. So x y square is the answer. So this is the del dot A, divergent of a vector. So this is the del dot A. You find the divergent of A. One step is finishing. At that point 1 minus 1 1. When then substitute the point x y z. So this is point x direction, y direction and z direction. So x y z is equal to 1 and minus 1 and 1. Then this value is substitute that this equation del dot A. So what is the x? X is 1, z is 1. Y square means that is 1. Y square means minus 1. So minus 1 whole square, and z means 1. So 1 whole square. Plus x means 1, y is equal to minus 1 whole square. So minus 1 whole square means plus 1. So 2, then 1 minus, then simplification this value, and x, y, z kada. So this is the 2, then ikkada right missing 2. 2 into x z, so that is 2, and minus 6, 1 into 1 1, so minus 6, plus, and k, that is 1 minus 1 whole square is equal to 1. So then simplification, 2 minus 6 plus 1, so what is minus 3. So del dot A is equal to what is the value? Then 3. This is simplification. Just one, then substitute this point. Another one, no need. What is find out the divergent of A? So del dot A, this value only. Okay, this is most important problems. Divergent, and another one is curl also. So again, when R is a position vector, that is I, position vector means that is I x y z plus z k. So I can you find the del dot R. So what is the value? You can find that this value is del dot R is equal to 3. So same simplification. This is, so again, and again, and next one. So same simplification of curl method. So that is the curl of a vector. So yesterday's problem. What is the formula? Curl a or any vector. So here see, R is the position vector. R is the position. So see this. R is the position vector. R is the position vector means that is xi plus yj plus zk. Okay, this is the position vector. That is means R is equal to of a point. Then show that the curl R is equal to 0. Then we can find that value, that is curl R. Curl R means that is del cross R. You can write anyone. Del cross R or curl R. So what is the formula? Ijk dou by dou x dou by dou y dou by dou z, ax a by az. Okay, so what is the ax y z? Then I term x and y term z, y term vector field A, and z term. So you can write that what is the value of then here curl R. Then R. This is the R, not A. This is R. So why? That is this is R. Del cross A. You can write A. Curl R. That is R. You can write. So Rx, Ry, Rz. So Rx term means that is I term. So Rx means I. That is I x plus yj plus zk. So I term means x, and z term means y, and k term means z. So here, so this is this det is cross multiplication. First of all, I is close. This term is close. So that is cross multiplication. This one. You can first cross multiplication this one. So see, I is the cross. I is close. So I close చేసినప్పుడు మనకి క్రాస్ మల్టిప్లికేషన్ లో ఎలా రాస్తాం? డో z by డో y. So this is the డో z by డో y minus డో, next one, this one, డో y by డో z. This one, first dou z by dou y, and next one dou y by dou z. This is the item. And similarly z term is close, this type. So ijk close, and z term is also close. Z term is close. Then first of all, this one, it can dou x by dou z. Dou x by dou z. Again dou z by dou x, that is minus term. So and this is first cross multiplication, and this one, and again k term. So this is k is the close, k term is closest. So dou y by dou x, dou y by dou x, and dou x by dou y. This is the dou x by dou y. So here say observe dou z by dou y. So that is with respect to y. Now, so that is z. What is the derivation of this value is 0. And again with respect to z. So what is the term y? So that is the also 0. And this is the differentiating with respect to z term with x. So that's why this is also 0. And this one with respect to x, and this term is z term. So this is also 0. And this is also with respect to x, and that is the y term. And with respect to y, this is also x. So this is also 0. This is also 0. This is also 0. Del cross r is equal to 0. Then r is the position vector. What is the curl of position vector is equal to 0. Another one, what is r is the position vector, the divergent of a r, and del dot r. What is the del dot r value is 3. So that is differences of curl and divergent. Only divergent means that is the cross product, that is product, only product, and cross product is det, that is the formula. And this is the one method of the simplification. This is vector curl of a vector field. This formula is also, this theorem is also proved last class. And divergent of a vector field. So this now we these are the theorem is also discussion. So already discussed చేసేసాము divergent and curl theorems. This is one method of this so one curl problem, and another one divergent problem. So these problems are very important. And again one more problem. See, curl, say here observe that is the a is the vector, a is the vector. Then find the value of curl a at a point 1 minus 1 1. So what is the curl means del cross a. So what is, this is the formula. What is the a x a y a z, that is the I term, z term, and k term. So you can write this I term y, and z term is x square plus y square, and k term is k y z plus zx. Okay, this is also same method. Then cross multiplication. Okay, so cross multiplication చేసినట్లయితే మీరు see cross multiplication చేసినట్లయితే this value see this is cross multiplication, dou y by dou x, x square plus y square. So see, dou by dou z into x square minus x square plus y square. See, and dou y by dou y is the 1, and with respect to dou by dou x, so ikkada I term and z term and k term. So I term is close చేసినప్పుడు dou by dou y into yz plus zx. So this close this term, this is cross multiplication. Okay, so here see this item cross multiplication, j term and k term. Here this is the simplification with respect to y, so that is z, and no y term, that is the 0. So z minus 0. And similarly that is z term. So here is also with no z term, so that is x and y is the also constant, this is the 0. So only this one dou dou y by dou y is 1, so that is only z. And same similarly z term, so with respect to z, so no z here, So that's why that is 0. And with respect to x, so this term is y and z is constant, that is 0. So plus with respect to x kabatti minus this minus plus into minus minus and z, dou x by dou x is 1, z is constant. Similarly, like that this value is also. So what is the x square with respect to x square? Then x square means 2x. Y term is also constant, that is 0. And this is the minus 1. So dou y by dou y is my 1, that is 1. So simplify iz minus jz plus k 2x minus 1. So what is the, this is curl A. Curl A, what is curl A? I z minus j z plus k into 2x minus 1. Similarly, what is the point? That is point is substituting x, y, z. This is x, y, z. This values is substituting in this equation. Then simplify I minus j plus k. So x is the 1, y is the minus 1, z is the 1. Then simplify I minus j plus k. This is the curl A value. Okay, another model is the curl problems. Okay, curl and divergent problems is very important. Okay, this is one type of curl problems and divergent. So these theorems are very important. And curl of a vector field, okay, and Gauss theorem, Gauss divergence theorem, that means Stokes theorem, and again vector integrations. Okay, don't write what is your name, Khan. So vector integrations, Stokes theorem, Gauss divergence theorem, curl of a vector field, and models of the divergent problems and curl problems. These are topic is finishing. Okay, and next class we now we have to discuss make then kinetic topic. It is the collision. What is Newton's laws? Newton laws are 3 Newton laws. One is 3 laws. Newton, how many laws? Newton laws is 3. First one is every body tends to be in a state of rest or in a uniform motion unless an external force is applied. That is the Newton's first law. And what is the Newton's second law? That is F is equal to ma. The force acting on a body is equal to the rate of charge of momentum. That is called, then simplify, F is equal to ma. What is the Newton's third law? Newton's third law, for every action there will be an equal and opposite action. So F action is equal to F reaction. That is 3 laws of Newton's laws. So that is based on this kinetic related topic. So next class lo kinetic theorems gurinchi explain chestam. So Raj. And okay, bye everyone. Next class lo meet avudam. So, WhatsApp group. Raj missing. Okay. Okay, right, everyone. Bye.